Welcome back to Statistics on Catalyst University. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. In this video, we're going to talk about linear regression analysis. And there's generally two kinds of that. There is simple linear regression, which is where you have a y and an x variable, and that's it. And then there's another kind, which is multiple linear regression, which is where you have, generally speaking, one y variable, but you can have many x variables, or many what we would call predictor or independent variables. Okay, and it turns out that when you do this in Excel, and you do this when you have the analysis tool pack, it's very easy to do both of these. In fact, it's pretty much about the same amount of work. If you need help installing that data analysis add-in into Excel, I have another video where I explain very briefly how to do that. I will put that link in the description of this video and all other videos in this playlist. Okay? So, let's go through the theory of regression analysis, linear that is. So, in linear regression analysis, now this is a very general statement and there are some exceptions, but for the most part, if you're doing this particularly in biology, chemistry, really any of the STEM fields, almost always both the dependent and all independent variables are continuous. You can have some exceptions, but for the most part, everything that I've ever dealt with, all the variables, regardless of whether they're dependent or independent, are continuous. Okay? You cannot have categorical variables. You cannot have ordinal variables. They have to be numbers, we'll say at the very least, but generally they're all continuous. Now, in both cases, whether it's simple or multiple regression analysis, you can only have one dependent variable. Okay? You can only have one dependent. It doesn't matter if it's simple or multiple regression. That's like saying it can only have one y variable. Okay? Now, simple regression has one x variable. So simple regression can only have one independent variable. Multiple regression can have as many independent or x variables as you want. In fact, multiple regression, I mean, it's probably not practical, and I can't really think of any example where you would have this. You could have 500 x variables in multiple regression. They probably wouldn't all survive the analysis, but you can have as many variables as you want. But in general, the best way to think about this is really just you can only have one y variable. You can only have one dependent variable. It doesn't matter. You can have as many x variables as you want. If you have more than one x variable, it just changes what you look at a little bit. And that's what we're going to talk about here. When you do simple regression, you have one y, you have one x. One dependent, one independent. So the variables that you might be looking for are an r-squared value. This is called the coefficient of determination, but most people refer to it as simply r-squared. In both cases, r-squared values, they tell you what percent of the y variable is explained by the x variable. So if you got an r-squared of 0.8, that's 80%. That means that 80% of the y is explained by the x. Okay? It basically just tells you that 20% of it is not explained by the x variables that you have. Okay? The adjusted r-squared is also something that can be important. The adjusted r-squared is always lower than this r-squared. The normal r-squared, this is the r-squared that arises due to only the data that you have in your study. So for example, if you had, let's say, 10 values of y and 10 values of x, that r-squared is calculated using those 10 values. Okay? It doesn't use anything else, obviously, because you only have 10. It uses everything in your study and nothing more. Okay? The adjusted r-squared takes into account the fact that you might actually eventually add more data points. So I said we have 10 data points. Well, suppose I go and collect 5 more data points. So that would be 15, right? So I have points 11, 12, 13, 14, and 15. I don't have those yet, but I might in the future. So the adjusted r-squared accounts for data that you don't have yet. It's how well does the computer think your model will fit future data. So it's a little bit more conservative, so the r-squared is lowered just a little bit. It's usually not lower that much, but it is lower than the normal r-squared. But it takes into account data that you might get in the future. Okay? Not stuff that you already have. Then you have a p-value, and the p-value, sometimes called the significance f, the p-value is how statistically significant is your model. Obviously, for the p-value, you want it to be as low as possible generally, okay? And normally, when we use a 95% confidence level, the p-value is going to be 0.05, and so we want the p-value that we get to be less than 0.05, okay? Then we have coefficients. This is going to help determine our model, and we'll actually look at the coefficients whenever we actually go to the Excel file. Multiple regression, we have pretty much all the same stuff. We also have coefficients, but we have one for every x value. We have a p-value, also called a significance f there as well. The only thing that's different is that we have, instead of an r squared, it's called a multiple r squared because we have multiple x variables. So whenever we look at these, we actually need to look at the multiple r squared, okay? But it means the same thing as this r squared virtually. The multiple r squared means that, let's say we have a multiple r squared of 0.9. That means that 90% of our y variable is explained by all of our x's. And that would also mean 10% of the y is not explained by the x's that we have. That means there's probably maybe another variable that we didn't measure that we should look into, okay? The adjusted r squared, this also, if you do multiple regression, you might as well call this multiple adjusted r squared, but they'll just call it adjusted r squared. And it means basically the same thing it did up here. If you've got a bunch of data points, the multiple r squared calculates that r squared based only on the data that you have. Okay? The multiple adjusted r squared takes into account data that you might get in the future, but you don't have yet and is not in your Excel file. How well will your model fit future data? Okay? So now that we've beat this theory to death, let's go and look at actually running a multiple regression. Okay? 3 things I'm going to preface here. 1, I use the Mac version of Excel, so the Windows version is going to differ ever so slightly, but it is basically, for all intents and purposes, the same. 2, if you have not yet downloaded the Data Analysis Tool Pack, go ahead and do so, or go see the video, which I have linked in the description, where I show you how to download the Data Analysis Tool Pack. And then 3 is the actual data I have here itself. So I've got a y variable here. This is my dependent variable. When I do multiple regression, I'm only allowed to have one dependent variable. However, the independent variables, which are my x's, x1 and x2 here, I can have as many of those as I want. So I can have one dependent, but I could have 50 independent variables. 50 x variables, okay? I can have as many of these as I want. I only have 2 here just to illustrate the point, okay? So let's actually do the multiple regression. All right, so what I'm going to do is go to Data, and then I'm going to go to Data Analysis. And what I'm going to do is go to Regression. So this regression will cover both simple regression and multiple regression, any regression that you have that's linear. If you do anything that's non-linear, you have to do some transformations of this, and that's a different video. So what I'm going to do is input the y range. All you do is just the one y variable, the one dependent variable, okay? The x range, okay, for this, let's suppose I had x variables that went out to column J. What I would literally do is put all of them in this x list, okay? Now I only have 2 x's, so I'm just going to do these obviously, but if you had 50 x variables, you would just drag this thing way out there. You put all the x variables in like this. That's all there is to it. If you want to change the confidence level, you can. If not, by default, it's 95. But if you wanted to change it to, say, maybe you're being really stringent, 99%, you would just do that. We're going to keep it at 95, okay? Then I'm going to select my output range. Let's do that. Let me put the output range down here. And then that's pretty much all you need to do for basic stuff. You can play around with these at the bottom. They're really not super important unless you have a reason to do them. So I'm just going to hit OK. And here's my information. All right, let's go through probably the important things here. This r squared is a multiple r squared, even though it doesn't say that. So it is your multiple coefficient of determination. Okay, we see it's 0.91 approximately. Okay, you would report this. Some people might also like this adjusted r squared. It's an adjusted multiple r squared. Okay, I can even make this wider so you can see more there. The difference between these, the r squared, the simple one, this multiple r squared, that one is an r squared based solely on the data that you gave in this table. So how many rows of data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are basically 12 data points. So 12 y's and 12 x1s and 12 x2s, so 12 overall. Given only those 12 data points, this is the r squared that came directly out of that data. Okay? What then is the adjusted r squared? The adjusted multiple r squared it's slightly more conservative. As you can see, it's a lower r squared, but it takes into account if I had more data points. So notice, for example, I don't have data points in rows 14, 15, and 16 here. But I could always add more data points. I don't have them yet, but I could take more measurements, do more experimentation, get more data points. This adjusted r squared takes that into account, that I could get more data points, and it's a little bit more conservative because I don't know what those data points are. So how well would this model fit new data that I do not have currently? Okay? And some people might like to report both of these. Okay? Now, the significance of this relationship is determined by this p-value. It does not say p-value. When you run this multiple regression in Excel, it will actually say significance f. This is your p-value though, so let me actually make a note of that. That is your p-value. So you can see it's 1.994. This e is times 10 to the negative fifth. So about 2 times 10 to the negative fifth, that is well below 0.05. So whatever relationship came out of this, it is significant overall. Okay? So that's important. The F statistic right here can be important if you're determining if there's difference between the two x values. So is there a difference between x1 and x2? And there clearly is, which is why the f value is so high, but generally you would not need to report this value. Okay, the p-value though, the significance f, is very important. Now, suppose I wanted to construct a relationship out of these. How would I do this? Well, there's several ways you can do it, and what I'm actually going to do is I'm going to merge some cells together. So let me actually go to Home, merge these cells. I'm actually going to write the relationship between all of these variables, all right? Because ultimately what I'd like to do is construct an equation. It's always going to be y equals, and how do I determine what everything is? Well, here I have the coefficient of the first x variable. I see that it's 0.118, we'll say. I also know the coefficient of the second x variable, x2, is 0.049. And then I also have the y-intercept. So literally, when I go and type this in, it's just going to be 0.118 x1, all right, let me do capital X1, plus, and I'm going to take the second coefficient, 0.0, let's say 49, times x2, and then I would just add on my y-intercept, which it happens to be negative, so it's going to be plus a negative, or just minus 5.2, let's say 49, okay? So that is my relationship. That is the model of this data. Now, how did I know to include both x1 and x2? Because sometimes in multiple regression, particularly if you have a lot of variables, some of them don't survive and you won't include them. How do I know to include both x1 and x2? Well, what I do is I go look at the p-value for each of the corresponding x variables. If that p-value is less than 0.05, then that variable is significant to the relationship and the model. So in this case, both variables x1 and x2, they are both below 0.05, therefore they are both significant contributors to this model. So I include them both. If, for example, I had a third variable and its p-value is like 0.6, I would not include that one. even though I put an x3 into the regression. I would not put x variable 3 into the model because 0.6 is much greater than 0.05. Therefore, this variable, hypothetically, is not significant in contributing to the model. Okay? All right. And then the only other thing that's really important to understand is actually what it means. So given this data, all right, and let's actually just look at the regular multiple r squared, although you can make the same argument with the adjusted r squared. My multiple r squared is 0.91 basically, all right, because we'll just round this to 0.91. What that means, and this is a hypothetical data set, normally they don't come out this nicely, but this means that 0.91, 91% of all of this y variable, any time I take this y variable, 91% of the time, it is explained solely by these two x variables, which is very powerful. That means 91% of the time, if I want to predict this y variable, whatever it happens to be, all I need are two x variables. 9% of the time, because 100% minus 91% is 9, 9% of the time there's another variable that's a predictor. Okay, there might be some other x3 or x4 that I didn't measure that helps predict it 9% of the time. But 91% of the time, these two x variables predict the y variable. Okay, and so just in general, like linear regression, like simple linear regression, that is, higher r squared means a better relationship. So you generally want a higher r squared value. But this one, just keep in mind, is a multiple r squared because we're doing multiple regression. And basically, that's all there is to it. Just understanding the important points here. You construct your model, and that's pretty much it. Thank you for watching this video. Make sure to like and subscribe.